Welcome to ClickMyProject.com. Project title: Optimal and Maximized Configurable Power-Saving Protocols for Corona-Based Wireless Sensor Networks. Let's see the abstract. Wireless sensor networks is organized as a corona for achieving low overhead routing. We propose a optimal and maximized configurable power-saving protocol called Readme. The protocol is included with some specific features to increase the performance of the network. The simulation results outperforms the existing power-saving protocol for corona-based wireless sensor networks. The result is obtained in the analysis of the performance of the simulation. Now, see the flow diagram. First, the network is formed with a number of sensor nodes. Then, construct the cycle pattern. This is based on the corona. The cycle pattern is constructed. If validated, means if it constructs a successful pattern, then it performs the ATF configuration. This configuration includes the cycle length and the cycle pattern rule. After that, the Greenmark protocol implementation is processed for performing the packet transmission, and finally the performance evaluation is done, which is between the existing and the proposed system. Let's see the running procedure of our process. First, to run our code, open the terminal window. Then go to the directory where we have the code. Then type ms space filename.tcl. Now number of nodes is created as 50 and the coding is running now. This is a network animator window. Here only we can see the simulation result. To run the simulation, press play button. This is the base station and these are the sensor nodes that are deployed in the network. Each and every sensor node have given specific energy to sense the data from its transmission range. Now all nodes are deployed in the network and now the corona network formation is processed. That is, the network is formed as the cyclic pattern, that is corona based topology is formed. It is done by using the cyclic pattern construction, and after that it is validated with the base station, that is the corona is formed perfectly or not. It is validated. So after this formation, the node transfers data, that is a source node transfers data to the base station. Here all the sensor nodes are the source nodes. The only sink is the base station. By our process, the wake up and sleep scheduling are processed here. The source node transfers data to the intermediate node and then it goes to the sleep state. Then it forwards to the base station and again it goes to the sleep state. If your node have data, it changes to the wake up state, that is represented in this color. It changes the wake up state and then transfers packets to the next hop, that is in next ring, next cycle node. Like that it forwards the data until it reaches the base station. After it transfers data, it goes to the sleep state. Like this process, if a sensor nodes generate data, it continuously transfers to the base station with the wake up and sleep scheduling process. This is the green map implementation. Uh, we see the results in the graph. So back to the terminal window and type GNU plot graph one dot, that is graph name dot plot. Now we see the output graph. It is the graph for the event to sync delay versus the network lifetime. The event to sync delay is source and destination delay and the lifetime of the network, which is calculated in seconds. Here we calculated the result as the protocol have less network lifetime than the green mag. That is, the green mag have increased the lifetime of the network. Then to see the another graph, type GNU plot graph 2 dot plot. Here to that delay, the throughput is calculated. The throughput is measured in kilobits per second. The existing green mag have less throughput, but by using the green mag, we have achieved higher throughput than the existing system green mag. This thus the performance of the network using the green mag is increased.